I want to give you a little disclaimer before we proceed to integrate shaders with Manem. The Manem shaders integration process shown in this video is for Manem GL version. I haven't tested this feature in the Manem CE version, but I guess with a few little tweaks it would work. We know that in Manem, DAM objects are designed by the arrangement of points on the canvas, and the location of these points are stored in terms of Cartesian coordinates x, y, and z. Any curve defined in Manem has three control points, and its curvature is governed by the mathematics of Bezier curves. Now, Manem stores the information of these points, the coordinates of these points, as an object's attribute called data. And if I want to access this information, Manem provides a method mObject.getPoints, which essentially is returning mObject.dataPoint. Now, depending on the type of mObject, I will get different information when I access mObject.data. To understand it clearly, I define a square, and if I type sk.data, we can see every information required to render the square on the canvas, the data type used, and the length of the vector. For instance, point here is a data name, and f4 is the bytes data type, and this tuple 3 here is a data length. It signifies that the point information about this square is stored in the data attribute as a tuple of 3 elements, which is x, y, and z, basically the Cartesian coordinates. And in the same way, we have the information about the stroke RGBA, stroke width, and many more. This data attribute acts as a medium to communicate between the scene and the shaders. I don't want to overwhelm you right now, but there is a lot of going on in this black box. From the scene to the camera to the shader wrapper and to the texture and back to the camera and finally to the file writer to write to a video. But among all this integrated structure, among all this maze, I need you to focus only on one thing for now. Somewhere in the middle of this maze, we have two shader files, word.glsl and frag.glsl. These files have unique role in OpenGL shading language or GLSL that we will visit in a more detail in the next video. In essence, these files modify the data which is extracted by the texture of modern GL setup within the Manem's camera or window to render it. Now, to facilitate this process, I created another scene class called shader scene, which you can access from my GitHub repo. This shader scene class is a subclass of interactive scene and consists of two main class attributes, shader folder and shader class. In the shader folder, we need to pass the path of the folder where the shader files are situated. And I want to specify that the folder path must be relative to the Python script file. Suppose I have my animation code in some Python file shader tutorial, and I set the value of shader folder to my first shader. Then the folder of the name my first shader must be in the same directory as the shader tutorial file. And inside that shader folder, there must be two files with the exact names, frag.glsl and word.glsl. And don't you worry, if somehow you forget to create these files or if Manem doesn't find these files in a directory, Manem will implicitly create these files with the default format. And also, if the shader folder is set to none, which is its default value, then the files will be created in the folder matching the scene class name, the class that you want to animate. Let's see how can we code this shader scene class. I'm defining my scene which inherits all of the features from the shader scene class, and I'm going to run this scene in the embed mode. That way I have full control in the console window. So these are the two files, word.glsl and frag.glsl. And this is a basic default format that we need the shaders to run in the Manem. And don't worry, we'll visit each and every line in both of these files in my next video. But first, let's just ensure that everything's working fine. So I head on to the frag.glsl file And let's say I want to change the color in the frag color variable. So after making that change and to refresh it, I need to pass the command self.refresh shader in the console window. And that updates my shader canvas. See, everything's working fine. Now, as I said earlier, we'll visit each and every line in both of these files in my next video. Try to experiment with the colors here. Change the values of RGBA in the frag color and see if everything's working fine. And in any case, if you have any doubts, feel free to let me know in the comment section or open a discussion in the GitHub repo. And thanks for watching. I'll see you in the next video.